All right, students. So going back to this, we were going to do number 9. Okay, and it says that a function has derivatives of all order x equal to 0 at x equal to 0. And let the polynomial, the nth degree polynomial, and this is the Taylor polynomial, although we also know it's the Maclaurin. Maclaurin is the same as the Taylor except at x equal to 0. And it is known these values. We know these values. And they want us to find this guy right here. So probably the first thing to do is if we have the first degree polynomial and we have the second degree polynomial, we know the value is evaluated at 3. Let us expand this and then start substituting in things that we know. So this would be f of 0 plus f prime of 0, x to the first power, divided by 1 factorial, plus f double prime of 0, x to the second power, divided by 2 factorial, which is 2. Okay, so this is our expansion for the nth degree, and we're doing the second degree. So what do we know? We know this value here. We don't know what this value is, and we don't know what the second derivative is. So we don't know first derivative, and we don't know second derivative. So, but we do know for this first degree that if I substitute in 3, I would get 5. So why don't we do that? F of 0 is equal to 8, so I'm going to have that. Plus, I don't know my first derivative, so I'm going to have f prime of 0. And x to the first power. Now, I know if I substitute in 3, I'm going to get 5. So I'm going to put 3 in for that, 3 in for that. So what is this going to be? This is going to be 5 is equal to 8 plus f prime of 0 multiplied by 3. So if I subtract 8, I'm going to get negative 3 is equal to 3 times f prime of 0. And so that means f prime of 0 is equal to negative 1. So now I can take this value and I can now substitute it into here. And I know this one already. So if I go back to the second degree polynomial, I've got this. I've got 8 minus 1 x to the first power plus the second derivative evaluated at 0 divided by 2 x to the second power. So now if I just replace all my x's with 3, I will have negative 11 is equal to 8 minus 1 times 3 plus the second derivative of 0 at 0 divided by 2, and then I've got 3 squared. So what's 8 minus 3? That's 5. Okay, so negative 11 is equal to 5 plus 9 halves times the second derivative at 0. And so when I subtract, I'm going to get negative 16 is equal to 9 halves f double prime of 0. And so multiply by 2 and divide by 9, I'm going to have f double prime of 0 is equal to negative 32 over 9. And that would be my answer. And so this is how you would read a problem like that. Okay.